Hello, my name is Edwin Perez. My research presentation today is on 5G network design and applications suitable for 5G technology. The first paper article on my research is 5G radio network design, ultra reliable low latency communication, and it essentially outlines the components and requirements um, for ultra reliable low latency communication system. Uh, what is 5G? 5G, in simple words, is the latest cellular technology. Uh, what do we get from 5G? Faster connectivity speeds, ultra low latency, greater bandwidth, and some of all the benefits from 5G technology come in the advancement of societies, transformation of industries, and enhancement of day-to-day experiences. Two key segments discussed on the article are massive machine type communication, and that is essentially um, connectivity between sensor devices and the IoT. Another segment, what is discussed in great detail, is ultra reliable low latency communication. Uh, what is low latency? Well, low latency is the round trip delay on a transmission process. Now, ultra reliable low latency communication, um, it is addressed on 5G as the need for low latency in certain services and reliability requirements have grown stricter. Some of the applications for ultra reliable low latency are industrial automation, smart grid, remote health, and smart transportation. All of these applications have in common the fact that uh, delays on transmission can result in loss of money, loss of life. Um, so it is important for to have systems that can support these applications. What are the requirements for low latency? The requirements established by ITU and 3GPP, which are global organizations that set standards for cellular technology, are that the system can to be capable of to transmit 32 byte message over 5G radio interface within 1 millisecond with a 1 minus 10 to the minus 5 probability. And this figure here, it turns to be 99.999%. 3GPP further requires that the system be able to achieve a latency of half a millisecond, and that is based on uh, the average for multiple transmissions. Uh, Also, the latencies laid out in this paper are only a fraction of the latency budget. It is recommended that other measures to be taken to keep uh, the latency low or to minimize it. Um, some key components of the for the design of a low latency system are waveform and radio slot structure. Now here, the system is based on orthogonal frequency division multiplexing, which allows to minimize transmission interference. Um, and this system, a cyclic prefix is implemented, and what that allows is to protect um, data from adjacent interference. A key component of the waveform regular structure is sub-carrier spacing, and here we have that for LTE or current or previous technology, whatever we want to call it. The spacing is fixed at 15 kilohertz. On new radio technology, which is the technology mostly used for 5G, we have 15, 30, and 60 kilohertz below the 6 gigahertz frequency, and 60 and 120 above the 6 gigahertz frequency. Now, lower numerology, meaning lower frequency, are mostly used for large cell sizes. That's because low frequencies can travel further. Higher frequencies used for small cell sizes, and that is because they high frequency signals tend to degrade over distance. Um, Slots, these are components of the subcarrier system, and here we have the slot consists of 14 OFDM symbols that are transmitted within a transmission time interval. Different numerologies, they result in different slot lengths. They range from 1 millisecond at 15 kilohertz, which is what we use for LTE, to 125 microseconds at 120 kilohertz, and this is using the new radio technology. Now, also another concept implemented within the slot and system is mini slots. And mini slots are usually used for low priority data. On long-term evolution OT systems, ultra reliable low latency communication enhancements are based on FDD, frequency division duplexing, and spectrum efficiency. On new radio, they're based on enhancements based on time division duplexing. Another important aspect of low latency transmission is the resource and channel access, the resource assignment and channel access. Now, the idea here is to use all resources to minimize delays and maximize latency. Fast data processing in the network and user interface, short turnaround, allow more retransmission, scheduling, which is a key component of resource allocation, in mobile communications, and is usually done by algorithms. And the uplink, which means is from user equipment to base stations. Delays are usually caused by scheduling requests. Therefore, changes had to be done on the transmission grants between user interface, user equipment, and base station. Now, the change that was established to counter that is the assignment of is the use of semi-precision scheduling, which assigns a periodic grant when there's data to transmit. Otherwise, it's not used. Also, here we have the concept of preemption, and this is where high priority data takes precedence over low priority data and can use low priority data resources. When it comes to reliability, again, I discussed this on previous slides, but again, here we can see 99.99 probability of success with 1 millisecond latency. Here, the error is limited to 0.001%, And the transmission of a packet is a function of several components of the system. Therefore, we must ensure that they are reliable to be able to meet established requirements. Now, how can we achieve ultra reliable transmission? Uh, if we have a fading channel, we can implement significant SNR margins or signal to noise ratio margins. Also, we can use diversity in the time domain by repetition of feedback. On the frequency domain, we can use the channel the channel properties parameters to our advantage by utilizing frequency hopping or distributed resource mapping. On the spatial domain, we can use different configurations of antennas depending on our needs. Um, on the new radio technology, uh, flexible channels for uplink and downlink transmission have been established, and also a low density Perez check. And now what this allows is transmission errors to be corrected on the go, and high coding gains at low code rates. On long-term evolution, we use turbo codes for data channels or our read molar codes for our control channels. Now, also another aspect to consider on for reliable communications is multi-connectivity. And here we can consider multi-connectivity as the user equipment connecting to a radio network through multiple carriers. Here there are two main methods for this: carrier aggregation, and this allows multiple transmission over wireless channels, and it allows for sharing of channel capacity. Also here, a centralized scheduler distributes packets and allocates resources and based on known conditions on the channels and of the different carriers. The other method of multi-connectivity is dual connectivity. Here, aggregation point is through the packet data convergence protocol, and these protocol mainly used on new radio technology the allows more than one MAC protocol to be executed at once. Now both methods are utilized to improve reliability other than or beyond the physical layer of the network. Now, and a key component of communications and is the use of the spectrum. And to use the spectrum efficiently, it is considered that the best method is retransmission only based on feedback or when needed. The next paper on my analysis is the applications of 5G. Here, the article is titled 5G Communications Overview on of vehicle to everything drones and healthcare. And this focuses on the limitations of technology and possible solutions on the following areas: vehicle to everything communication, UAVs, and healthcare. Now, some background on 5G communications and applications. Now, 5G is the next generation of wireless technology, again, needs considered to be capable of connecting to anything, anywhere, and anyhow, regardless of where. Uh, Now, this is a big a shift from previous, from early technologies, and new radio technology uses high carrier frequency with massive bandwidth, increased antennas, screen based stations, device density, and are bound by latency, strict latency and reliability requirements. Now, some applications of 5G communications, vehicle-to-work communication, UAVs, healthcare, utilities, industrial, VR or AR, and broadband services. Now, on this slide, we can see some background information as to why we want vehicles to communicate with each other, and this is largely to avoid car accidents, or in simpler words, for safety reasons, to improve safety on the roads. Now, the main idea of this is using existing and emerging communications infrastructure to improve road and road conditions and safety. Here we have an illustration of some of the technologies used for each of these categories. Now, the vehicle-to-vehicle communication is primary for autonomous or driverless vehicles, and most important for commercial emergency vehicles. Now, the main purpose of the vehicle-to-vehicle communication is for it to be able to perform long-term trajectory decisions, considering near proximity of cars, hazards, or other. Now, the connection is bounded by strict quality of service requirements. Now, some of the solutions that are proposed on the paper are using different technologies to enable channel utilization to be better, and to prioritize data sharing. In this case, a millimeter wave is one of the technologies recommended. There are other technologies or other proposals as far as vehicle-to-vehicle communication. Now, there are techniques and theories that are used to determine possible scenarios on vehicle safety, and also to based on those scenarios that can be simulated, we can allow autonomous vehicles to take better decisions. Now, pedestrian safety is another key aspect of wireless vehicle networks, and here we have three main components. Now, one of the components is to develop applications based on real data that can alert pedestrians on crosswalks, etc. And also other technologies that can be used to alert pedestrians to cross or not to cross a road. Also, another segment of vehicle communication is vehicle to infrastructure, and essentially here what we have is a vehicle communicating with the surroundings. Light signals, cameras, parking meters, etc. Some of the proposed solutions based on a vehicle to infrastructure um, technology or systems is setting up a system consisting of several components. Onboard unit, which is a unit in the car, and roadside unit, and both of these can communicate and and allow for safer um, roads. Uh, Another approach to infrastructure communication is a multi-tier heterogeneous wireless network using different technologies. Now, here's the breakdown of some of the technologies. Also here, we have some specifics on the dedicated short-range communication system based on these technologies. Uh, now, now we also must consider intra-vehicle communication, which this is essentially the communication of the vehicle systems and sensors and for safety, um, data control, driver assistance are the main categories. Um, Here, a key component of on this section is the camera, radar, and ultrasonic sensors, which provide the driver with data relating to the driving environment. Now, here are some of the solutions that are proposed to be implemented is break down data in categories. Now implementation of next generation Ethernet, which means wire connections with additional hardware if required. Now security concerns are in place. Um, some of the challenges to the challenges and solutions to technology concerns are for IE 802.11p. There's a great delay in the signal and the transmission when the network load increases. Only is considered to be suitable for low data, low rate data stream. Um, Transmission range is short, and utilization of spectrum is not efficient. To overcome the deficiencies laid out above, a new enhanced system is launched based on different coding mechanisms to address existing concerns. Uh, Concerns on the LT system primarily are since the system is designed for MBB services. Uh, Now, some of the limitations are latency, no direct transmission between source and destination, inefficient transmission of data packets, poor coverage. Now, on 3GPP Advanced Pro, some of these issues were somewhat addressed, yet the main limitations remain in place regarding to latency, etc. Um, uh, Millimeter wave technology, this is actually the solution to all of the issues laid out in previous slides on as far as technology for vehicle to vehicle communication. And now we move to another application, which is UAVs. And UAVs are usually deployed in terms of communication when there are emergencies, etc. And what they do, they form a bridge between areas where or nodes where infrastructure is damaged. So it becomes a communications bridge between network nodes. Now, UAVs can be deployed in the form of single deployment or multiple deployment. Single deployment only serves as a bridge between two nodes. Optimal location based on software, and it searches for the best location for the um, uh, UAV based on signal to noise ratio, throughput, and bit error rate. Multiple UAV deployments are this happens if a single UAV cannot cover all required area, and basically its location and placement is based on software. Also considering that collision avoidance measurements need to be in place. Uh, LTE only supports UAVs at low altitude. Uh, Now, concerns on past technology are the same as in other applications: latency, bandwidth, data rate, etc. Now, the biggest advantage comes in real-time surveillance and monitoring applications, as there's a greater bandwidth, a greater transmission data rate, and there's still concerns on security. Lastly, is the application on healthcare. Technology has become a key part of healthcare industry because of the need of treatment or assistance in healthcare. Now, here are some applications. Some of the key applications are, and most important applications, in my opinion, are remote surgery, uh, tracking of patients, etc. Uh, Now, similar to the case of vehicles and UAVs, the limitations of current cell systems are largely in terms of latency, data transmission, and integration. Some improvement expected from 5G technology: low latency, high data rate, flexibility of device integration with is known to have been a problem with current technology in terms of cost and implementation. This concludes my presentation. I hope everyone enjoys. Thank you.